Hi, David and G here. Today we're gonna look at some limits. Today we're gonna determine some limits at infinity by using some algebra. So let's get started, right? So in the first expression, if you just substitute infinity on the bottom, it wouldn't really means anything, right? So how about you kind of using algebra to manipulate it a little bit? So let's write it in the form of phi x over x plus sine x over x. So that is something you learn, right? That is something you learn is that you in an expression like this, you can separate it into two expression like this, right? So let's look at this. So we have x and x. So x can cancel. So that will just give us 5 on the left, and then we have sine x over x. What if x is infinity? Like remember the I introduced in my last video why this will be equal to 0, because if you have a very big number on the bottom, it will be like a very big fraction. So for example, let's write that on the blue pen again, because so this is not part of our example. So let's say we have 10 1 over 10. What is that? 0.1. What about 100 over 10? I mean 1 over 100, right? That's going to 0.01. What about 1 over 1,000? 0.001, right? So you see, as the bottom number increases, which is what the limit does, I mean what the infinity does, right, is a very big value. So as that values increase on the bottom, the number gets smaller and smaller and closer to 0. So we can therefore conclude that if we substitute infinity on the bottom, this will give us 0. So we can rewrite the expression as 5 plus 0. So which will just give us 5 for this expression. So for this one, we're going to do the same thing as what we did here to separate the two into two fractions, which will give us 3x squared over x squared plus 1 over x squared, right? So like ask yourself what you can cancel here. Well, obviously we have x squared and x squared, so x squared and x squared can cancel, which will give us 3 on the left side. And then again we have a situation where if x is on the bottom, so substitute bottom as infinity, it will give us 0 as I explained here. So we can just write it as 3 plus 0, which is equal to 3. And then we have cos 1 over x. So in this case, remember you don't want to because you cannot simplify no more here. So let's say what you get as 1. So what happens when you substitute infinity under expression like this? So what is 1 over infinity? Like I explained here, it's 0. So therefore we can rewrite the expression as cos of 0. What is cos of 0? Well, it's 1. Well, that is how you kind of things you could do with manipulating algebra. So the key thing is that first you want to kind of like what I did here is to manipulate algebra and move it around a little bit and cancel as much as thing you can, and then try to get like a number long, right? So you realize how these two expressions always have like a constant when I cancel all these common terms, right? So kind of sometimes that's what you want to get in the test. Otherwise, you get functions like this, because the test is not going to give out like polynomials or other kind of like more complicated situations. So one thing to see if you're correct on that answer or not is that to check if you have one of the constant appear on here, and then one of expressions like 1 over x, 1 over infinity, or sin x over infinity, right? So kind of you need to understand that is to manipulate the algebra, and then to cancel the common term, and then substitute infinity in, then get the 0, get the constant, plus them together or minus together, and do whatever you can, and then you will probably get like an answer.